Today, we will present our simulation project of check-in process in AMC Empire 25. We have Yuqian Liu, Peter Ni, Qing Yuan, and Tingwei Zhang. AMC Empire 25 is a cinema complex just off Times Square, showing mainstream and IMAX film on 25 screens. However, online rating of this theater is very low. Most of bad reviews complain about disorganized lobby and uncomfortable seats. The theater was built in 1912. The lobby was not designed to contain that many people. Therefore, we built up a simulation model imitates real check-in process in AMC Empire 25 and developed an improved model to address latent problems of theater operation. Our goal is to minimize the overall waiting time through entire check-in process. But our data collection, AMC Empire 25 does not have accurate attendance data available, so our group carry out field data collection by ourselves during weekends. Our 4 group members plus 1 volunteer friend went to theater during 5 p.m. to 9 p.m. on a weekend evening. There are 8 tickets vending machines and 4 counter servers working at that time. We collect 5 different arrival rates and processing rates at the same time for 4 hours. We assumed all customers are served in groups throughout the entire check-in process. Peter counted how many groups arrived without tickets entered through the front gate as customer arrival rate. Tingwei counted how many groups go to escalator directly after entrance as rate of customer with ticket. Yuqian counted how many groups purchased ticket through counter, and I count how many groups purchased ticket at vending machine. Our volunteer friends count how many groups went through the check-in upstairs. We assume each group of customers will arrive by ticket and check in together at the same time. Customer arrival rate is correlated with different time period in a day, and we only observe the business operation time of theater. We assumed all staff were uniform and won't affect our observation. Also, customer flow time in theater is not considered, and no AMC staff VIP queue, and no re-enter customers in our simulation model. Next, I will pass to Peter to give us more details about our workflow.
This workflow diagram is the blueprint for our simulation model. Customer could buy the ticket online in advance. Therefore, we had 2 distinct types of the customer groups, one with the tickets, one without the tickets at arrival. They were the entity for our simulations. The groups bought the ticket online would receive the digital confirmation code on their phone, so they would directly go to the 3rd floor for checking via the escalator. The group without the tickets must line out to purchase physical tickets at the lobby. There were 2 waiting queues, one for the self-service vending machines and the other for the full-service counters. In our case, there would be 8 vending machines and 4 counter servers during the Sunday rush hour. Likewise, they would take the escalator to the 3rd floor for check-in. The 3rd floor had only 2 check-in stands, with 1 ticket checker for each. The check-in stand 1 had the access to Theater 9 to 25, whereas the check-in stand 2 was the entrance for Theater 2 to 8. Next, we use one of Arena tools called Input Analyzer to fit models for our collect data. We only consider the top 3 candidate models with lowest mean squared error, MSE, for each of our observation data. As you can see, the gamma distribution has the lowest MSE for the arrival interval time for the groups without the tickets. This gamma distribution has the estimate parameter beta 0.196 and alpha 0.914. We chose the exponential distribution with mean 0.467 for the modeling the arrival interval time for the group with the tickets. Because the exponential distribution is memoryless, which manifests each arrival interval time was independent of the other. For the machine service time, we prefer the log normal distribution with mean of 4.2 and a variance 6.32 because log normal was best fit to address the data skewness. For counter service time, we also favor log normal distribution with the intercept 1 and mean 4.93 and the variance 10.8 in consideration of the data skewness. For the check-in service time, the exponential distribution with intercept 0.03 and mean 0.193 had the lowest MSE with the decent model simplicity. Next, I pass to the Yuqian for the simulation.
So based on the flowchart we just went through, create this model in Arena. Basically, we have 5 distributions and 3 queues in our system. So for a customer without ticket, after they enter this AMC, they have to decide to buy ticket at a counter or at a machine. In this decide mode, we use the two-way by chance type. Around 31.6% of customers will choose to buy the ticket at the counter, and 68.4% of customers will go to machine directly. This number was calculated based on our observations from 5 p.m. to 9 p.m. on May 7, using the equations here. The counter customer count divided by entrance customer count minus elevator customer count. Then we ran the simulation with 50 replications to generate the first report. The length of each run was 30 minutes. In report 1, there are about 230 customers entering into the system. The average waiting time for the check-in queue on third floor is about 2 minutes. The average waiting time for counter sales queue is about 5.89 minutes, and the average waiting time for machine sales is about 4.95 minutes. So after finishing the first scenario, I did the model validation by comparing the output from our model and the real system based on the observations we got on April 29th. For consistency, I used the observations we recorded after 5 p.m. on last Sunday. Then I calculated the proportion of customers with the ticket of total customer entered into the AMC. You can see the difference between two systems is less than 4%. For 3 queues, I compared the average processing time and got the difference between real system and our simulation model. Therefore, we can see that our model is authentic for simulation. So after that, we did the second scenario. In the second scenario, we changed the arrangement of our resources, which is the number of counter, machine, and check-in staff to improve our performance of the model. We added 2 counters, 2 machines and on the first floor, and another 1 check-in staff on the third floor. In the second report, there are about 233 customers enter the system. The average waiting time for check-in queue is about 0.12 minutes. The average waiting time for counter sales queue is about 2.91 minutes, and the average waiting time for machine sales is about 3.37 minutes, which reduced a lot comparing to the first scenario.
Here comes our summary. So based on our observation and simulation model, we came up with the better arrangement of the theater resource by relocating more steps to check-in stands or counters and adding 2 more vending machines. Check-in queue time could be reduced by 94.2%, and counter queue time could be reduced by 50.6%, and machine queue time could be reduced by 31.9%. And we have 4 recommendations for the AMC Empire 25 Theater. The first recommendation is to encourage customers to buy tickets online. In addition to its own ticketing platform, amctheater.com, AMC is also the shareholder of other 2 large online movie ticket platforms, movietickets.com and Fandango. So we recommend AMC to encourage their customers to book tickets online. The second recommendation is to relocate more staff to lobby. During our observation at the theater, we found that there's only one customer service desk with 4 staffs on the 3rd floor, and those 4 staffs were idle 80% of the time. So we recommend the theater to relocate 2 staffs from to upstairs and set up a new customer service desk at the lobby. These 2 staffs could help to assign customer waiting in the queue to empty vending machine and to assist customers to operate the vending machine. Our third recommendation is to put up signs at the entrance to direct customer with digital tickets to escalator. Customer with digital tickets can check in directly, but during our observation, we found that there were still a number of customers redeemed their tickets at the lobby. So we recommend the theater to put up signs at the entrance to remind customers with digital tickets that they do not need to print out a paper-based one. Our final recommendation is to put up signs on the 3rd floor to direct customers to the right check-in stand. During our observation, we found that customers usually go directly to the first check-in after they get off the escalator, and 1 in 7 of them would be redirected to the second check-in stand. So we recommend the theater to put up signs on the 3rd floor to direct customers to the right check-in. Here is our references, and we are open to questions.